Welcome to Study Loop.
Okay, our question says that a projectile is launched from ground level to the top of a cliff, which is 195 meters away and 135 meters high. And they say, see figure 60 to see a diagram of this. If the projectile lands on top of the cliff after 6.6 seconds, find the initial velocity of the projectile, both magnitude and direction. And we can ignore air resistance for this problem. So I wrote out here what we were given. That was x is 195 meters, the distance in the x direction it travels. The cliff is 135 meters high, so it has to travel that high to get on top of the cliff. So that's y. It starts out at 0 meters, so y naught is 0. And the time it takes for it to get there, the time of flight is 6.6 seconds. So then it wants us to find the total initial velocity, v of 0, in both magnitude and direction. Well, one thing we can find is we can find the velocity in the x direction and the velocity in the y direction and use those to find the velocity in the total velocity. So let's first find the velocity in the x direction. Should be straightforward since we know that x, the distance in the x direction, is v of x times the time it travels. We know x and we know t, so we can straightforward solve for v of x. That's going to be equal to x over t, which is 195 meters divided by t, which is 6.6 seconds. Okay, so if you plug that into your calculator, you find that v of x is equal to 29.55 meters per second. Okay, so we know v of x. Now let's see if we can find v of y. Well, we can use our equation for the height of the projectile y is equal to the initial height, y naught, plus the velocity in the y direction, times the time it travels, plus 1/2 the acceleration in the y direction, times the time it travels squared. Okay? Well, let's go ahead and simplify this a little bit. Y is equal to, y naught here was 0, so let's just ignore that. V of y, still don't know, that's what we're trying to find, times the time, plus, well, it says plus 1/2 a of y times t squared. Well, the acceleration of y is gravity in the negative y direction. So we'll pull that negative sign out front, and this will be minus 1/2 gravity times the time squared. Okay, well, v of y is what we're trying to find. So let's go ahead and rearrange this equation, solving for v of y. And that's going to be equal to, well, the first thing is y plus 1/2 g of t squared. And then to get the y by itself, we have to divide by t. So this is all divided by t. Okay, so now if you plug in all the values for y, g, and t, y is 135 meters, g is 9.8 meters per second squared, t is 6.6 seconds. So plug all those values in, and you'll find that v of y comes out to 52.79 meters. Okay. Meters per second, excuse me, because it's velocity. Meters per second. Okay, well, you have the velocity in the y direction. If we're just drawing this out in form of triangles, v of y is that way. You have the velocity in the x direction is that way. So the total velocity, v naught, is there. Okay. These are perpendicular to each other, right? Okay, and here is the angle. So this is v of y. This is v of x. So then you can see here, using Pythagorean theorem, we can find v naught. V naught is going to be equal to the square root of the sum of the squares of both sides. So it would be v of x squared plus v of y squared. So for v of x, you plug in 52.79, square that, add that to, or I'm sorry, for v of x, you plug in 29.55. And this is meters per second. I forgot my units earlier. Let's put those in. 29.55 meters per second squared plus 52.79 meters per second squared. Take the square root of all that. You find that this comes out to equal 60 meters per second. So that's magnitude, but it said magnitude and direction being theta. So let's see if we can find theta. Well, we can use the trigonometric identity, which says that tangent theta is equal to the opposite over the adjacent, which would be v of y, divided by the adjacent, v of x. Well, we know v of y and v of x, so let's solve for theta. Now, if you do that, you find that theta is equal to the inverse tangent, write as tangent to the minus 1, of v of y over v of x. So the inverse tangent of the ratio v of y to v of x, v of y again being 52.79, v of x being 29.55. Plug those in, take the inverse tangent of that, and you find that this is equal to 61 degrees. So now we have found both magnitude and direction.